First, we will ask the question, what is root locus?
This is a very useful way to predict the behavior of a closed-loop system as some parameters of the system are changing. Typically, it is the gain. Here is a closed-loop system with a variable k. The transfer function of this system is shown. We have poles when the value on the circle is equal to 0, which gives us the simplified characterization equation shown. Now we will start with the real stuff with sketching the root locus. We will start with the first rule. The first rule states that the number of branches is equal to the number of poles. In this example, we have 3 poles. The second rule tells us that there is symmetry with respect to the real axis. The poles marked in X can only go to a 0 or to infinity. Poles cannot go to each other. Poles and zeros existing on the real axis only exist to the left of the odd numbers of them. Asymptotes guide the poles as S goes to infinity. Basically, we need to know where the asymptotes intersect and their angle. Rule 6. Breakout and endpoints. Breakout points occur when this formula is equal to 0. This polynomial has two roots at s equal minus 2.5 and minus 0.78. We will disregard the minus 2.5 because poles are only to the left of the odd numbers. Rule 7. Angle of departure. The angle of departure only occurs when we have a complex pole. We will take another example to see it since we don't have any complex rules in our previous example. First, we must know that the angle of departure is 180 plus the sum of all the angles to this particular pole to 0 minus the sum of all the other angles to this pole. So here we have an example. After calculating all the angles to zeros and poles, we can find the angle of departure. The angle of departure is shown in gray in this graph. The angle of arrival is just the opposite, occurring when there is a complex zero. Finally, when will the poles cross the imaginary axis? These values are normally determined by using Routh method. By finding the k value that will give us the 0 row, we can find these numbers. That's the end of our video. Hope you understood root locus.